Well, so last time we covered a record number of patterns, and we'll start covering. We'll get to the confusing part of the course now, because the patterns should start to look similar. And so there are a few patterns in the gang of four which are somewhat difficult, right? The visitor pattern is one of them. The chain of responsibility is another one, but for a different reason. Oh, come on, that's problem. And so basically, the chain of responsibility, we're going to build up a class by chaining things together. So we define some sort of interface for what a handler does. It may have more than one method. We only show one method handle request, but there could be 10 different methods in our handler. And then usually each concrete handler only does one thing. And so if you've got 10 methods, you might have 10 handlers, each one handling a different method. And then what you do is you build these things up, and that becomes your object. And then you interact with the outermost one. So the complication here isn't understanding what they're doing, and that's, I think from now on, there's only like one pattern where it's slightly confusing how it works. How it works is going to be fairly straightforward from now on. The question is, why, right? Why would you ever do this? And so, several more examples. One is when you send a method to an object, how do you find that method? Well, you start at that class and you look there, right? If it's not there, what do? You go up to its parent class, look there, right? If it's not there, you keep on going up this chain, right? And so we've been dealing conceptually with chains all along, right? Text talks about, help system where, contextual help, a dialogue might have a help, or this button may have a help, or this list may have a help. But the question is, what happens if that help isn't good enough or particular which doesn't have a help, right? So you build up this chain of, well, here you start with this help system and that leads you to this help system. And so you build this chain where, okay, right, the cancel button has a handler, and if I can't answer your question, it goes up to, inside the dialogue, and then it goes up to the application, right? And so we get this chain of responsibility. And one thing you note is that this won't happen in Java, but it can happen in Python, right? Where you send a method to a class and you look at the class and it's not there, and you go to this parent class, it's not there, you keep on going the chain, and it just may not be there, right? And so in the chain of responsibility, you build up this chain, and then you ask the first thing, do it, but the chain may not handle it, right? Same thing with, this help system. You ask the question, and no one may know about it, right? So then the answer is, don't know. In this case, if it's not there, then you get a runtime error, right? Another example is, here we are, Apple Mail, You can have filters, right, to filter your mail and say, oh, do this. So, in this case, want to build a special rule. If you get an email from the UIUC patterns group, you put it in this folder, right? You may have another rule, oh, get email from this person, just delete it, right? And so you get more and more rules as you go along, right? And so what do you do when you get an email, right? You build up this chain, you say, does this rule apply? Yes or no? Does this rule apply? Yes or no, right? And as soon as one rule applies, you apply it and we're done, right? So again, we can implement what AppleMail does with their filters by using this chain of responsibility. Each rule becomes an element of this chain. We chain them together and so question, is this like decision trees? No, it's subtly different, right? One is decision trees, you start at one branch and then there's multiple paths you can go, right? Depending upon what the answers are. Even if we go here, right? We got a tree structure, but we start at the bottom. And when you start at a particular point, there's only one path through. And when you come to a handle that deals with it, we're done. It doesn't go any further, right? Yeah, it's bottom to top. And once you come across the handle that handles it, we're done. We don't pass it on, right? Where the decision tree is like, we're trying to find the leaf, right? We go all the way to the bottom, and here's the answer. So again, we could have each rule be a handler, and we just create this chain, and each new email comes in, we, pass it to the chain, and as soon as one handler it triggers my rule, it processes it and doesn't pass that request on to the next element in the chain. A bunch of other examples you can look up. They get more and more obscure in a sense of, servlet filters. Well, if you don't deal with servlets, then they're not going to make much sense. Microsoft Global Keystrokes. Okay, but if you don't program Microsoft Windows, it's not going to make much sense. Apache has a library for chaining events together. Another example is we can build logging systems, and you may want to do multiple things, right? Often you just when you have a logger, you'd write to a file, but you may want to go to a file and go to standard out so you can see it, but have a record of it. And so we can build different loggers and then combine them together. And then when we trigger the log, we send it down that chain. Yeah. Well, here it's just, trying to pass the message on. So it's just implement is pretty simple because you have an interface and you get one more message that will happen. And you typically either handle it or you pass it on to the next one. Pretty straightforward. Now, since you studied some of the old exams, you could start talking about some terms you came across, like what is this all about? Um, we all know recursion, right? You have a function and it calls itself. When it calls itself, it somehow reduces the input somehow so that eventually we get down to a base case and stop calling ourselves, right? Otherwise, it becomes infinite. What is object-oriented recursion? Well, instead of the function calling itself, we don't have functions, we have methods, right? So we send the same message to a different object, right? We've seen this example before where I've got, this linked list, and I define toString on it, right? And what do we do is, well, the head node is going to do something and then call toString on the next thing, right? So it's calling the same method on a different object, but again, somehow the input has to decrease so that eventually we come to a base case or end case, right? So then it goes to node and several nodes, and finally it goes down, right? So it looks just like recursion, right? You're calling the same method toString on an object, but the object we're sending it to changes. So people call it object-oriented recursion. And again, I could do the same thing, add and delete and all kinds of stuff, right? So we start getting things which start to look somewhat similar in the sense of object recursion. What we're doing is we're sending the same message to a different object, but we do the same thing in the chain of responsibility, right? And then we'll see this when we go to the decorator soon. We'll see a similar type behavior. So what's the difference between object recursion and chain of responsibility? Yeah, I mean, chain of responsibility, we're not guaranteed that we'll handle a message, whereas object recursion, it's like recursion, what's our base case, right?
It seems like chain actually production environment or something. The hierarchy of responsibility doesn't really need, whereas recursion generally goes here to here to here to here to here. It doesn't really there isn't one child per node. Whereas with chain of responsibility, you probably if the situation.
Yeah, but typically on the chain of responsibility, you may have a tree structure, but you start at the bottom, so there's one path from where you are to the end, right?
Okay. Well, there's a difference than you're starting at the bottom.
Yeah, so one difference, like I said, is we're not guaranteed to end. And you usually know recursion, we expect to go all the way back down and all the way back, right? With a chain, once you handle it, we usually stop and we're done. A similar pattern, pipes and filters. Any Unix fans out there? It's a similar thing, right? You've got pipes, right? And you build this chain of commands and you pipe them together, right? And you pipe, here it is, the ls, and you send it output to grep, and then you can send it to word count, right? And so you build up this chain. So it's very similar to chain of responsibility, except these pipes, right? And then they don't stop. They go, you start at the beginning and you pipe and pipe and pipe, and then you get the output, right? So it's not quite the same idea as the chain of responsibility. Plus, you're not calling the same method. You're just taking the output of one and making the input of the next. Right? So you just, Unix is built on this idea, right? We start with these small little things, and then we can combine them together with pipes to build some pretty amazing things.
So they're actually pattern title pipes.
Yeah. And it's not in the Gang of Four textbook, right? And this is a description, right? It's processing data streams, right? And you build a system that transform the data that goes to the stream, right? And that's what Unix does. In some sense, a lot of functional programming does this, right? You build a stream of things, you pipe in data one in, it flows through, and you get the answer at the other end. And so it's much easier to build small things with independent, so do that, and then build a way of combining them together. Right? And this is a very common. Right? So there's a data source and the pipe that goes into the next filter, and finally the output comes out at the end, right? And there are different ways we can deal with this. One is in Unix, right? The data source pushes, right? When I do an ls, it's going to push the output to the next thing in the stream, right? But we could have just the reverse, where we have our data sync ask for the next value, right? I need the next answer, and then it pulls data. And then it asks for the filter, give me your next thing, and that filter asks the previous filter, give me the next thing, and the filter then asks the data source, give me your first thing, give me the next thing. Right, and that's it's used in a number of places. And these days people now build data streams. Like in big data, you have all these sources of data, multiple sources, and they start sending it to various databases, and you start pulling and create this stream of data to process it. And for the Python people, right? How does Python work? Well, they got this, stream, and the compilers or the interpreters built in different segments, and they pass each other.
Topic, but what's the structure and abstract?
Great question. I'm not sure what they consider the difference. Another example is on the server side, when you get a web request, there's often a number of things you need to do. Is the user logged in, right? Are they authorized to do whatever they're asking to do? Can they access this page? Is it a valid request or not, right? And so a lot of web frameworks now, what you do is you build handlers to handle the pre-processing and the post-processing, so you don't have to worry about that in your main application. When it comes to you, it's already made sure you're authorized to access this page, and made sure that the request is valid, all kinds of stuff. So you're just handle the main case. And having this big if statement or case statement makes it hard. Well, you build handlers and you basically say, look, here are my 5 handlers I want to stream through. Have you checked for cross script? You need to give a token, right? So when they come back, you have the token, so you know that it came from someone didn't intercept it. You don't want to deal with that in your main code, right? You want to have it just done for you. Logging, I mean, again, there's all these things where you want to.
So this is the there's just we saw the Tomcats. So actually, is that because just and
And here's where I get to the point where I said in the beginning of class, where it starts to get confusing, right? One is a chain responsibility, and one's a pipe and a filter. So one difference is on the pipes and filters, you expect it to go all the way through, right? It's going to go through. Chain responsibility, you expect it, at some point when I handle it, I'm done, right? Now for me, at some point, when we talk about the adapter and the proxy, they're all going to start looking the same. For me, what's important is there's certain basic ideas here that we can use to attack problems, right? And the key thing is remember these ideas so that, are we talking about chain responsibility in service, or are we talking about pipes and filters, right? Well, we're talking about breaking these things up into smaller pieces, and we want to do some pre-processing, right, to make the main case easier. Yeah, guard, well, yeah, guards are a way of separating out, here are the edge cases and here's the main case, right? Making sure that data is ready for the main case. It simplifies our work. We don't have to have this case statement and build nesting. It's like, okay, well, if I expect a number between 1 and 50, have a guard less than 0, okay, then forget it. If it's greater than 50, forget it. Now I know I'm in the right range. I can do the right processing. So we could almost consider that inside the method almost like a chain responsibility, right? Okay, it's -5, so forget it. Oh, it's greater than 50, forget it, right? It depends upon how you handle the guards, right? If a guard is, it's less than 0, so return, we're done, right? Then it becomes more like chain responsibility, right? Because you're going to go step through and when you handle it, we're done, right? You don't go any further. But yeah, right. So you start seeing some of the basic ideas repeating, right? It's like, okay, you don't want to handle everything at once, right? It's too complicated. So how can we make our life easier, right? In Unix, it's just build a bunch of small little stuff, right? And then we combine them together, build something bigger. Using guards, okay, we've all these edge cases. We don't want to. We want to make our main case easy, right? So forget about the edge cases, handle them in guards. And using pipes and filters, now you can combine them right at runtime. You can, right? So that's pipes and filters. So the decorator, and adapter, and proxy are going to look very similar. And so first, you have your assignment, mock objects. If you're a Java person, Mockito is pretty popular to create mock objects for you. So you don't have to do it manually. Python people, there's a built-in library that comes with Python that does it. The Swift people, there's no mock object library. There's a posting that talks about how to build your own mocks. What's a mock object? And why would you want one, right? A mock object is what it says, right? It's not a real object. It pretends to be an object. So on your assignment, you got several problems, right? So the big problem is you want to build listeners or observers. So when a web page changes, we trigger actions, right? The problem is, do you have control over when those web pages change? No. So how are you going to test to make sure the code works, right? Unless you create your own web page, you can modify it by hand and then run your code. It's hard to tell, right? Plus, if you want to write automated tests, you can't automate, modifying a web page and send a server and all that sort of stuff, right? So what we want is some way of creating a fake object to request that has this web page changed or not, right? And so in the Java world, you create can I remember them all? One that comes to mind is just in Swift, where I create a URL connection object and say, here's my URL, give me the contents, right? So on Swift, we could create an object which has the same interface as URL connection, right? Now is there a copy, right? Because the problem is, if it's a copy, then when I call, get this URL, it's gonna open a network connection and try and get it. And as soon as we do that, we're dead, right? What we want is an object has the same interface as I get this URL, and instead of going to the network, it says, oh, the first time you call it, I'm going to give you this. The second time you call, I'm going to give you that, right? Right. So we could say, what we're really interested in is has the page changed, right? And so we really want to know the header. And so we may create a URL connection object and say, give me, the first time I'll give you a page that says that the date it changed was yesterday. Similar maybe, but we're making the data up, right? Whereas in views, you're combining existing data to.
So it's like a big slash placeholder.
It's like a stub out object, but it gives you data back, right? You could call a method on it and return something. It's pretending to be a connection to a web page, right? But it doesn't go now where you just say, give me this URL. Yeah, it's returning the information you would have gotten, but you make it up so that the first time the date it changed was yesterday, and the second time the date it changed was just now, right? Right.
This is a string. Yeah. Oh no. The program at all. This object.
Yeah, so there are two types of operations you can do in mock objects. Usually is you specify when this method is called, here's what you return. When it's called a second time, here's what you return, right? So we can specify based upon the method and the parameters what to return. The second thing they do is when you call a method, you can record that what was sent, right? And the third thing they do is mock objects, and those two libraries will mimic the real class. In Python, it's easy, right? Because all you have to do is implement the same methods, and then it works. In Java, it's more complicated. The Mockito, it'll say, you can say, look, I want this mock object to pretend it's that instance of that class. And it will then respond to all the same methods of that class, and the compiler will think it's an instance of that class. So I can pass it around wherever, any place where an object of that class can go, even though it's not. Yeah. Yeah, but usually, remember, the whole point is we're testing, right? So what feature are we testing, and what methods do you need from that object? Usually you don't need them all, right? Because what we're trying to test is not that object, but things that use that object. The whole point is learning new things, right? Besides, you want this thing to be automated, right? Or yeah, the problem we have here is that university environment is fake, right? The university environment is fake, right? You're taking a class and you turn the assignment in, you're done with it. But the problem is, you get in the real world, right? You're going to build systems, and you really want to know if they work. And if you build a system that talks to the network, you want to make sure it works. How do you do that without having to manually sit there and try and trigger all kinds of cases and then set up a server to respond in a certain way, right? Um, that that can be done, but it becomes harder because now you have to set up two machines, right? And then when you're done with running one test, you have to reset the other machine. How do you do that from one, right? That becomes very complicated. So how can we then isolate our system, our piece of code, to write, automated tests to test some of your code and that code depends upon resources off that machine. And as you can imagine, it happens a lot these days, right? I mean, and so these mock objects are a way of doing that. We then, you want to talk to a database? Oh, we'll create a mock object for, right, your database connection, and we'll specify what returns. Oh, you want to talk to a web page? Well, we'll mock an object to, right? Oh, you want to send an email? How do you test for that? Because are you going to then check to see if you actually received the email on an email address? So again, we'd want to then a mock object that responds to the same methods that you would have used normally, right? And then you want that mock object to record what it got, because then I can say, okay, it should have sent a message to this address with this content, right? And see if that was in the mock object. Now, one of the problems with mock objects is you have to be careful because you're faking it, right? And if you're not careful, if you fake it poorly, it's not going to mimic the real system, right? And so then you end up testing things which not applicable. So when you actually run the system, it breaks, right? Well, the problem with that is when do you want the web page to change? The problem with the course wiki is somewhat subtle, and that is it's the server is behind. It's using I want to say SSL, but it's TSL, and so there's a certificate, and the certificate company we're using isn't one of the big ones. They give us a certificate for free instead of charging us, $200 or whatever it normally is. And so not every system recognizes that certificate as being valid. What's that? Yes, and so if you're using Java, without making modifications, when you try and connect to it, it'll throw an exception. I don't know if Python cares or not. I don't recall. I mean,
More pushy.
yeah, it's a course in computer science to learn new things, right? Yeah, so one way to deal with that is um, what's the modification date on a particular web page, right? And you have to keep track of, remember, your system has to run for a long time, right? So when you first start up, you have to say, oh, give me the last modification date, right? And then when it changes, you have to say, oh, okay, every time you have a loop, it maybe waits every 10 minutes, right, or something, and say, give me your current modification date. Oh, has it changed yet, right? So when you start your system up, you can configure all those pages with a really old last modification date, right? You're thinking about it. No, you can do it for real, but when you first start your system, right, and you talk to a web page, has it changed? Because there's nothing previous, right? So all you do the first time is you record the last modified date, right? And then you record the last modified date. And then you keep on checking against that last modified date, right? And when you go to the web page and the date is after that one, then it's changed, right? So what happens when you start your system up, you tell it, oh, the last modified date for this URL was May 5th. Right. And so then you get one test, right? Because then the first time it looks, it's going to have changed. But it will trigger that. It will trigger your code. It has changed, right?
It's like thread.
Yeah. Right. To log in.
I don't use Reddit.
Usually, yeah. But usually, web pages that are generated from database don't include the last modified header. Now, I was going to have you handle that case too. And the way you would handle that case is you get the contents of the page, and then you would create a SHA hash of the page and store that. And then every time you fetch it again, you create the SHA hash and then compare it with the old one. And when they're different, then you very high probability that they changed, right? It's very unlikely that, right. There's in Java, there's a library which um, you give it a byte sequence and it'll create the SHA. Same thing there's one for Python, one for, it's a pretty common thing these days.
It's like a website.
Well, but how often are you going to pull it? In reality, if we're going to build the system, do you need to know every minute that something's changed or every hour? No. Yeah, I mean, that's how,
What's your tolerance?
right. Right. And, unless you're dealing with financial data or security data or, some critical, you want to know some, yeah, like, is there an earthquake coming? Is there a tsunami coming? Right? Where you've got 5 or 10 minutes. But other than that, I mean, if you want to know whether I've updated my web pages, I mean, once an hour is probably good enough, right? My guess is time progresses, there'll be more questions on the assignment.
Do you have any more slides?
Not yet. But it gives you a pointer, right? The singleton is one of the most controversial patterns. People like to argue about it. But it's very simple. Although in Java there's some really subtle issues. And so the whole intent is, yeah, we want make sure the class only has one instance and provide global access to it, right? And so here is a typical implementation in Java, although we'll see some refinements. So we have a static field, which textbook called instance. We hide the constructor, so you can't create it. The outside world cannot create an instance of the class. We have a static method that we use to get that instance, and it checks if the instance is null, it creates it, otherwise it returns it. Right? And so we ensure there's only one instance because we're hiding the constructor. Right? And we provide global access to it because we've got a static method that we can call from anywhere because classes are globally accessible in Java. I think I see a question being formulated. It's like a global variable, right? Yeah, I mean, that's why it's controversial, right? You just create a global variable. Although, well, but again, that just gives you an instance of that object, right? And then you can call whatever method exists on that object. You're ensuring that a class can be instantiated once. Kind of, but in that case, you don't need this to create the right your application. You can just hold the one model, and so we don't need a singleton. Okay, an example. So in Java, right, there is a security manager. So whenever your program accesses a system resource, a security manager is called to see if you have that authority. Now it's best known in applets, right? Because you don't want to allow applets to start reading and writing arbitrary files on your hard drive on your machine when the code comes from some remote machine, right? Because we know exactly what happened if you allowed that, right? If an applet you downloaded from a web page can start reading your hard drive, someone will write it and it'll spend all its time looking. Oh, look, there it is, a credit card number. I think I'll send that to China, right? Right. So every time, even on a standalone Java application, or even when you run a Java program, right, there's a security manager. Every time you access a file, right, security manager is called and says, does, right, this program have the ability to read files or write files? And there is a global file on your machine whenever you run Java that specifies what you can do on an application running on that machine. And so you can modify that to say, look, I don't want any Java program to write any file on my system. And you can do that, right? But we want to make sure that there is only one security manager in your application. Because there's two, right? If I can slip in a second one, then we might be able to slip in one that bypasses, right? And so how do we make sure that different parts of the Java library accesses the same security manager, right? So we need global access, but there's no way to pass it around because we're talking about the file class and the stream class and the network class, right? And different classes need to access the same security manager and they're not related. And so we want to make sure there's only one instance and the global access. Done, right? Now there's a number of different ways we can violate the singleton pattern. One is, like I said, I could have, I'm building an application, I want one model and a bunch of views, right? And so I'll make my model to be a singleton. Well, are we making a singleton because we're lazy or because we haven't thought enough? How can I make sure there's only one instance of my model in my application, right? So there are times people jump to a singleton when there are other ways to ensure that we only have one instance, right? Because we may want to have two models, right? Maybe we want to run a simulation and see what happens between the two models. So we want two models, right? And once you do a singleton, we can't do that. Standard out, right? You only want one standard out, right? And we also want global access to it. The standard out? Singleton, whatever, we're returning an object, right? What the object allows you to do, right? Right? I mean, you want to be able to access a logger from different places. We don't have to pass it around, right? Because, but also we want different parts of the system to access the same logger, right? And and we may change what parts they want, right? And so there's no way of knowing in advance how to architect a system to pass the same logger all over the place, right? And so just, okay, let's make it a singleton and now they can all access it, right?
Just today I was log objects for every class.
Yeah.
Now I realize I made a mistake.
So we just have one, right? Now the Java logger allows you to specify a logger per class. You may want to log different things in different classes. Yeah, the singleton is global to the whole system, right? And all objects. Yeah, particularly if no object doesn't contain state, then there's no reason to create bunches of them, right? Because if there's no state, then why just make it a singleton and then everyone gets the same one and we save space and right? What's that? Right. Right, you're giving it global access. Do you really need it, right? Or is there a way of architecting the system to pass that one thing around it? And again, there's different levels, right? If your singleton is immutable, then it's just basically a constant. So it's not like we have any dependencies where one piece of code will change the object and then another piece will read it, right? Singleton pattern, if you actually read the textbook, right, there's like a couple sentences where it says, but it allows to have multiple instances where you can modify it to keep track of how many you want to give out. That it asks, people complain about, well, do you want the class to keep track of how many instances it have, or should the factory method do that for you? It's hard to, if you want a subclass of your singleton, then it becomes hard to deal with that because you have to specify the class dot instance, right? Class instance. Yeah, and this is true. I've come across this problem. We have a singleton and you want to test it and it cumulative state, and then when you run the test a second time, you want them to start over again. But wait, it's the same singleton and the cumulative state, and so then you need a way of killing a singleton and recreating it, right? Oh yes, and in Java it gets really, really fun because what I gave you, the standard solution is depending upon the JVM to do the right thing, and since it wasn't synchronized, it doesn't do the right thing. The example I gave you. Yeah, you may not really want a singleton, right? Which means then you build your system on knowing it's globally accessible. Now we want multiple ones, and now I need to figure out how to pass it around, right, to create it. Yep. There are all kinds of subtle ways in which you singletons and Java aren't singletons. And we might get there. implementation. We could do this, right? That gives us global access, and there's only one. What's that? Yeah, there's no way of passing it around, right? It's just a class, yeah. So it's not as flexible. It's supposed to in Java, in the sense of the JVM goes through a lot of work to, when it loads the class, to load it in a single thread. The VM is supposed to prevent that from happening. So there's two features people want. Lazy, in the sense of you only create the singleton when you need it, as opposed to that previous solution, that counter will be created at load time. Because when you load a class, all the static fields are, in this case, it would be instantiated. So here is sort of the optimized version for Java. And it's sort of crazy. What's going on here is when a class is loaded, it instantiates its static fields. And a class is loaded the first time your code tries to reference it. And since this singleton holder is a private class, the only place it's going to be directly accessible is in this instance method, right? And so that class is not going to be loaded until we call this instance method, and when it's loaded, it's created, and then we have it, right? And the second time we call instance, that class is already loaded, and so there's no null check. We don't, right? So not only is it lazy, but we're not checking each time. It's very subtle. Right, there's no, in Swift we have a lazy modifier, but we don't in Java. Right, yeah. Yeah, yeah. I mean, this is using very JVM specific features, right? Of loading classes, and Python doesn't have that, and Swift doesn't have it. The Swift has got a lazy modifier, so you can use that. So this works, right? But it's not lazy. We'll create it immediately when the counter class is first referenced anywhere. This is thread safe, but synchronize has overhead in Java, because whenever you synchronize a method, it has to get a lock to make sure no other thread also has a lock, right? And then we get this null check, so this will be slower. Is that important to you? It depends upon, what your system is doing and how fast it has to respond, but this is going to be, synchronize has overhead, and so is a null check. It's not very much overhead, but it's overhead. And that's why in Java, vectors, all its methods are synchronized. But when you create array lists, they said, oh, okay, no, they will not synchronize. Because there are times that you may want to create a collection and a method and use it, and we're done. So why do you want the overhead synchronized when there's no possibility of it being thread? And lots of applications don't use threads, so why should we pay the overhead when we don't need it? Yeah, it's not going to work to create a generic singleton. We'll do the first example. Classes in Java can be garbage collected. Right? I mean, if a class is round along, if you got a server running for days or months, right? If a class is only rarely used, it may go days and days without being used. And if there's no code currently that can access that class, that class can be garbage collected. Which means the next time you call for that singleton, you're going to create a new one. And the singleton can maintain, if it maintains states, it will be a brand new one. You know, it's a very extreme edge case, right? That'll give you really subtle bugs. Yes, very hard. I mean, and almost impossible to make happen, right? Almost impossible to make happen. I tried. I mean, you just can't. How do you force a class to be garbage collected? But it can happen. When you run your program, you can turn off garbage collection of classes. No, not per class. You can say the garbage collector still runs in a garbage collect objects, but not classes. All classes. Always have to have a reference, right? Yeah, and the hard part is if you're building a library which uses singleton, it's out of your control, right? How do you make sure your library always has a, again, it's a very extreme example. It could happen. It's going to be very hard to make it happen. But when it does, it's going to be like, yeah, it's going to be hard to track down. And next time we'll look at a bunch of other ways Rails and Java.